Wait here. Oh, wait. Okay. Oh, evidence.
Hello, people joining from remote. Can you hear me?
Yes, we can.
Oh,
Yeah.
cool. I think we'll probably start a bit later than what we planned because there are probably still some people who has not arrived. Yeah, we just got
What are you doing? Please notice the breakfast that's in that other room over there.
A few are gonna be late. I was doing the setup in here.
Okay. Why, what's the problem?
These plugs are just not working. I just was, I mentioned it to the security guard and I thought I saw the guy come in, but I was.
Okay, the security guard might not be able to pass the message along. So.
I don't know if there's a way to.
Uh,
We could just all
well,
share
so
these
look,
plugs,
we're gonna get the plugs fixed. It might take a little bit. I assume you have some battery in.
I am actually, I was working it this morning.
Hello. I think we're starting now. Before like the session actually starts, I'll talk about a few points. So the first thing is that there is a code of conduct from the Linux Foundation events. The link is in the agenda or like everywhere in the issue in the session issue. So please read it and make sure you comply to the code of conduct. So the bathroom is it takes a walk. So if you need to go to the bathroom, please ask someone from Bloomberg to like escort you to the other end of the floor. And so if you, I've sent a detailed guide and I pinned it to the Slack channel. So if you're attending in person, you can read it about how to join the Wi-Fi. And everyone in the room should join the Zoom queue as a panelist. I think I've sent email to everyone in the room, so please check your mailbox for a link to join the Zoom call as a panelist so that we can join the same queue as the remote participants. And note to the session facilitators, please, before the session starts, ask like find volunteers to take notes and make sure that someone is monitoring the Zoom queue. I think me and Mateo will be primarily managing it because we're joining as co-host. I think that's all. The session should start now. And I think the first one is, Sean, you have the web server framework session. You can use Coding or like you can just join for your computer.
Yeah, I'm joining. I will just share it.
Hello, hello. No echo, great. Hey everyone.
Recording in progress.
Cool. So the first session for today would be to discuss about the web server framework group. There's a few people that attending a meeting. So there is Marco, Paolo, Wes, mostly some other people also join from time to time, Stephen, and maybe other people. And I'm trying to check also if there's other people. Yeah. Do we want to promote other people? Like there's attendees that are not panelists. Are we promoting them or?
Yeah, I think.
Yeah. I know, yeah. I get we can promote everyone. Okay, so there is no complete and official just roadmap on everything. The main topic for the web server framework group, and I think it's mostly a good discussion, and Marco also maybe you will want to join me a bit later just to discuss about this initiative. The main point is we have HTTP 1, 2, 3 that are technology stack that does exist, and how do we want to work around that? How do we want to improve some part of the stack that would be linked to the net module, DNS, everything that is used for HTTP, for web, and maybe even for other technology. Maybe other people want to also come join me, so I'm not the only one talking for 1 hour. No, like, I don't know if we want to start with maybe, do you want to like present a bit about Milo, part of it? Yeah, like there is no official agenda on specific point because like we don't have one topic to discuss. I think there is quite a lot of topic part of that, which could be great also for us to see on which order, what's really important, what do we want to focus and what would make sense for the project. I guess saying we don't want to support HTTP 1 won't be a discussion for today. So what, yeah.
I think we can start from the next HTTP and
Yeah.
the issue.
Yeah. Do you want to?
Yeah.
Okay.
Let me grab the issue and. Okay, so at the web server framework meetings, we started to have a chat about the future of the HTTP server and the various implementations. So we know that for the client there is Undici, but we don't have right now a counterpart for server. The main issue is that the complexity of managing the HTTP stack has become very high. And this comes from the problem that we kept building on top, adding new libraries on the HTTP stack to manage all the 3 HTTP server major. So we have the like HTTP 1.0 and 1.1 that are implemented natively. Then we have HTTP2 that uses the ng-TCP library and all that stack on top. And then we have HTTP3 that uses another library so a lot of dependencies to manage the whole stack. And also one of the main issues is that you need, for each HTTP version, you have a specific constructor. So if you want to build an HTTP2 server, you will have a HTTP2 server constructor and the same thing. And so the developer experience is not great, especially for high-level APIs and like compared to other more modern web frameworks and runtimes, I think the server HTTP module is a bit lackluster. So the idea that came from the discussion is to like start thinking on how we can change this and improve the developer experience, and probably like start building something from scratch that's specific to handle all 3 HTTP versions. So we created a repository called, I think, Next HTTP, where I started with a little proof of concept. The idea is to have the same constructor for HTTP server that basically handles all 3 versions, and then to have low-level abstractions of the TCP socket and the UDP socket, basically. So
What's the URL of the repo?
I think it's,
The Zoom link on the
Yeah.
chat.
Oh, okay.
Or like in the notes, if anyone can help me take notes. I'm
yeah,
very
it's
bad.
next HTTP. I think you reviewed my pull request. So
Yeah,
yeah. Yeah. So like if you're interested in HTTP and the future of HTTP, you should definitely join the web server framework. So my idea is to create so one of the also big problems is that socket implementation is not say HTTP specific. It's a quite general socket implementation, and it's quite hard to debug and to manage because it will impact also a lot of other users. So my idea was, okay, let's write let's start from the lowest level. Let's rewrite the TCP socket class where we just handle TCP sockets. And then we built on top from then, and probably like we would also need, as we implement other version, we will need to create like a UDP socket, and then you create a layer of abstraction on top, and you build an HTTP server class that wraps all these different sockets. And in all of this, it comes Milo as a WebAssembly library that we only use in the on the JavaScript side. So that would also remove a lot of complexity from the C++ layer. Like also given that LL HTTP is quite hard to, to debug and everything. So I don't have slides to show you, but this is the summary of the discussion. If you want to know more about it, you can join the web server framework, and there is a PR on the next HTTP repository. Like I think I will continue to work on the next HTTP like proof of concept. So yeah, maybe Paolo wanna talk about a bit about Milo. Paolo.
Maybe just before, but you have the question.
Okay.
Can you get the mic? I don't know how.
Yeah, I think we're doing my.
You're doing the mic thing?
Sorry.
They just, okay. So I have a couple of questions from my experience with Undici. The only way to support this in a reliable scenario, like there is phenomena, like despite being called HTTP, all the internals of those protocols are drastically different. Like there cannot be anything closer. Like there's absolutely they have nothing to state with near each other in terms of the complexity of the protocols, what needs to be done to handle them, to keep them secure, and so on. So what I'm not seeing here is this level of abstraction in between. And this is where that essentially I think you need to need some work, okay, on that front, because a lot of the inefficiencies that we have in our current HTTP 1 and 2 and so on implementation comes because of those inefficient abstractions that we have in between. So the design of that abstraction to enable max speed, the low level, I mean, okay, the low level bit, it's really important. Then there is then the second problem, it's like from my point of view, you should not expose the socket. Like I would go and be bold enough to say you should not expose in the socket. Okay, this is one of the biggest mistake done by our current HTTP implementation. And there is the socket, the request.socket API, and the fact that people dig deep into it. I don't know. Some people are nodding, so maybe you are familiar with the problem. But it's and the monkey patching and all the things that comes from it. Okay, you essentially keep the API as tight as possible so that there's no access to them. Like, should be completely shielded from my point of view. There need to be an escape hatch to go to the lower level, but it needs to be, this is an HTTP 1.1. It needs to be very clear. It's not the socket, okay? Because the socket means different things from an HTTP 1 to an HTTP 2. So, and then you have no one-to-one. Okay, so you essentially to go down. If you need to go down to the lower level of the networking, you should, but it needs to be, this is the HTTP 1, this is HTTP 2, this is HTTP 3. It's clear exactly what those are. So you can just go down one level, but there's no .socket, because the socket means different things on, like, it's the wrong abstraction, or saying it another way, keeping the socket as the abstraction layer is not correct, because it's lower. It means different things for the values implementation. Okay, so it's which, it's I want to bang my head in the wall, but this is my it's what it is. Okay, so, and this is one of the mistake of our HTTP current HTTP node. You didn't mention one other problem on that, on when you were describing the fact that we try to have the same API from HTTP 1, HTTP 2, but it's the same API. They try to quack the same API, but they are two completely different implementations. Okay, because the way HTTP 1.1 was built and written, it's tied up to the concept of the TCP socket, which you do not have in HTTP 2. So you cannot use any of the high-level code. So the solution, as you said, is splitting the two things. Okay. Last, you didn't mention the high-level API.
Yeah, because
sorry, but okay.
I
So
can add some stuff.
Yeah, but one of the problems that we have, it's stream-based. Okay, and
No streams.
it's streams based, and in order to read and write to it, you need to interact with these fake streams. I call them fake streams because they're real. One is totally fake. It quacks as a writable. It's just not a writable. Okay, and the other one is a readable, which is even doing buffering when buffering is not needed. So it's even, it's on the level of horribility, even on just pure over. Those two objects right now are pure overhead, like pure. Those are two objects that are pure overhead. So basically trying to following a pattern where you have a function being called and that function return the response using a sync await or even a context object like Koa does. Like, there's a lot of different API choices here, but the generic part is allow a flow where you return the value. Okay, you're not writing to something, but you chunk by chunk, but you give, it is the full stream of the response if I want a stream, or is a string, or is a buffer. Okay, because that is how you will be able to bypass a level of indirection, and that level of indirection we currently lose a lot of perf into that.
So one of the many ideas for the high-level implementation was to comply with web standards, so with the request and response object. Although I think there might be a bit of a performance issue because of how like you have to create response object, and then you have to write the object into a string. So there is a bit of back and forth into parsing, and so like this is something that obviously we should performance is, I think, one of the main objective, but also like being web compliant. I think it's one of the main points. And also I think we want to ship the new implementation as a separate package and as a native add-on, and like see how it goes and see if it sees some usage, then we might want to in the future implement it into core. But yeah, for the time being, I think separate package is the best course.
Yeah, I was gonna add on that just a little bit, but just,
I raised my hand over there.
oh, okay, yeah, my computer's over here, so I couldn't respond. I just wanted to just to respond to Mateo's comment just a little bit. One of the things that we've talked a lot about in this group is layering these APIs very similar to what Undici is doing. So I think this is, when we say web compatible at the high level API, I think that could imply that we're not also going to have high level APIs that are more performance oriented. So I think we could have both, I guess is what I'm, like, if we layer them correctly, like Undici is doing, I think we could achieve the performance and then have a web compat API that, like, if you really care about performance, we just note, you know, this is slightly less performant than the dropping down a layer, and dropping down a layer just removes, you know, maybe some helper APIs or something. And I think that's pretty, to me, that would be a pretty acceptable compromise to make sure we hit the performance targets while also hitting the web compat things, even though sometimes those are at odds with each other.
And on top of that, two things that Marco omitted for sake of simplicity. We have two also intention that we want to ship. The first one is that the one that you and James touched in the NodeConf last year, which basically means you start a server, you don't care which protocol you expose on the socket, so you can potentially handle all the three versions together, which means that you have to be implement the HTTP semantics at the very top level, I mean the 9110 RFC, and then implement the lower level API that speaks to different version of the protocol. So you can, for instance, at the same time open an HTTP 1 and 2 and 3 on the same instance. That's a generic intention. A second thing which is very, very important is that when we say about re-implementing the socket, re-implementing the TLS layer and so forth, we mean by scratch, which means that, for instance, this socket might not be streams at all, because we actually don't need them for this specific use case. So we might have a TCP socket which is not a stream, because it's only meant to be used by new API which don't need streams. So we get rid of the layered compatibility with the lower modules that we currently have in Node, like HTTP, HTTPS, NET, TLS, and so forth. We start scratch with a separate implementation that does not use streams, but can eventually give compatibility layer with streams. So for the most performant case, we don't use streams and we bypass all the fixed things that we have nowadays. And we can basically achieve new possibility. I know that's terrific. I realize that. I hope we finish in 10 years eventually, but that's another topic.
Yeah, I do agree that one of the mistakes, I think, is to overexpose low-level APIs. So like, I think it's important to expose just the HTTP server, do not expose the socket. Like, do not have streams, not use streams at all, but it is possible to plug in web streams for like compatibility. But yeah, I think this is yeah, this is the intention. And I think the fact that we have Milo or like as in the JavaScript side instead of the C++ layer, it helps a lot to keep the layers separate, because like this is like on the JavaScript side we can do the parsing of the like we return a buffer from the socket and we parse it with Milo, So it simplifies a lot the current state of the HTTP stack.
Do we have a clear idea yet what we want to, with the user experience? Oh, sorry. Oh, am I skipping by raising my hand in person? I'm charging. Okay, I'll do that next. Sorry, I've done it twice now. Do we have a clear picture on what we want the user experience to be when a request, we start a server that then exposes HTTP 1, 2, maybe in 3, all in one, and then a request comes in on HTTP 1, and the handling code that the user of this API is going to write now needs to say, oh, I received a request on HTTP 1. That means I can't use the features of HTTP 3. Like, do they need to then have a concept that, like, will this mean that the user land code was going to be doing all these sort of switches of like?
I think I mean, if you, okay. As far as I understood the RFC, but I have to double check them because I was looking basically at the RFC. Okay, a little bit of context. Nowadays, the standard for HTTP is split in basically 4 RFC. The 9110 is the HTTP semantics, which basically defines what is shared between the different implementation. For instance, the other fields exist in all the different implementation, right? But in HTTP 1 are text, in 3 are binary, right? To give you the context. Now, excuse me, the HTTP server is going to expose a 9110 semantics, which means that in theory, it doesn't even know there are 3 different versions of HTTP. You get the idea? So once you get the server, which is user-facing, you have no idea that which protocol you might be talking to. Of course, I'm pretty sure we're going to expose a debugging flag, say, oh, you are on HTTP 2. But for what is exposed by the API, at least in my vision, I see that we don't expose anything that is protocol-specific, unless, like Matteo say, we hijack the socket, and I'm borrowing the term from Fastify. Basically, we hijack the socket and or the reply, and at that point, it's the user responsibility to talk to the client in a proper way. But by default, we don't give any specific semantic to lower protocols. So also, that's also a very good way to keep it simple. We get a request, you get a reply, done. We don't expose any unneeded complexity, because the thing is that if we expose such an API, we allow dangerous things for the 5% of users that will use them, which, most of the time you don't need to worry about it. You just need to say, I want to return this, done. Next. I killed the conversation, amazing. If there is nobody else, I will briefly show you the latest version of Milo, along with some consideration on what I've discovered lately on wild. Ce l'hai pronto tu? Se ce l'hai pronto, sì. Lo faccio prima, sì. Sorry for the Italian folks. It was easy for us to, but I can. Oh, actually, I have to share my screen. Never mind. Give me a sec. Yeah, just
You just share screen from Zoom.
Okay, can I just share my screen? It's easier,
Yeah,
right?
yeah.
I just have to show this slide, so it's
Yeah,
probably
yeah.
fine. Okay. But we can't see it here, Joy. Can you see my screen on Zoom, right? Oh, okay. Now we can. Amazing. Okay, so this is the very last and final version of Milo, basically its API. It's pretty straightforward. The only thing that I really want to focus on are basically these 2 lines here. When basically you create a buffer and you allocate them basically a memory. I think it's echoing with the microphone. Let me move here. So basically, when you create a buffer in the WebAssembly space, and then when you have to send the data, you just do buffer.set basically here, and that's it. This is very important because one thing that I discovered, which is, to be honest, I borrowed from LLHTTP. I see how Fedor was doing that, and I implemented that, and it works just very fine. Is that you don't have to explicitly serialize or deserialize the data with WebAssembly. So once you allocate this data in the buffer, you're done. In other words, once we receive the data from the C++ socket, we store in the buffer, then it can be freely used between WebAssembly and JavaScript. That's it. Nowadays, when you use LLHTTP node, you basically the flow is like C++ socket goes to JavaScript. Then from JavaScript, you call the C++ parser by copying the same data all over again. Then you receive it back, which is a mess. Go for it.
You have forgot about async hooks.
I don't know anything about async hooks.
In between, there is also async hooks being called. So there are two transitions back and forth.
Yes.
So for every chunk.
But those will stay, right?
Hmm?
Those will stay. The async hooks. I'm not removing them. I mean,
Somebody knows my opinion. So
I mean, we could, but I mean, that's I see your point.
Yeah.
I see your point, yes. But so you see the idea. So the same data is copied like 5 times for no reason. In theory, this way with the WebAssembly, I can just copy once from C++ to JavaScript and eventually async hooks, but that's another topic. And you're done. Then basically, as you can see here, when you want to extract during a callback to see what is the, because actually one thing that changed from LLHTTP is invoking your callbacks for every new character. So for instance, if you have a, I don't know, a body which is, no, actually the body is, well, the header. Let's say you have an header value which is 20 characters long, the same callback is invoked 20 times for no reason. Milo only invoked that once with the good offset. So from with the size of 10, for instance, and you do the slice only once. In theory, you could even avoid the slice and do the subarray, which is not copying the data, but it's dangerous because we might overwrite the parser. Once again, that's another topic. And that's pretty much it. What is the very good part about this new web setup in WebAssembly? That each call I make to WebAssembly, back and forth, only sends and receives integers. And that's it. Because, for instance, this parser P is an integer, is a memory pointer. From and size are pointers. If I need to get the position, I pass the parser, I receive an integer back, which means that I could also remove from the very first version of Milo the wasm bin.gen layer from Rust. So we only expose a WebAssembly function now, which could in theory be used anywhere. Wasm time, for instance, we could do that, why not? And so forth. That's the idea. Now, that's the new Milo. Where I'm now, I'm fighting with the Undicita suite because it's extensive and I have a lot of edge cases. But basically, I started to make it run there because it's a very good case of JavaScript use. And after that, I will eventually move to Node, which I actually think to be easier because in Undicita, they have a lot of very weird edge cases that are testing, which we don't in Node for some reason. For some reason, I mean, that's a nightmare there. I mean, who the hell used the 100.3 code? The 100.3 code is killing me, that thing, the upgrade one. You know the deal. But that's it. Once I finish with Undici, I will eventually switch to Node. Also, the good thing about having this way rather than on the very first version, I can also maintain LLHTTP in the code base. So both in Undici and in Node, so I can ship as an experimental parser like we did several versions ago when we switched from HTTP parser to LLHTTP. So we can have the same with the experimental flag, easier. The only things that I also currently missing in Node is I have to, and I actually need your input on this. I need to also migrate the connection list that is currently in Node from C++ eventually to Rust in WebAssembly. Because I plan to remove the C++ Node HTTP parser completely in the future. So that's something.
Somebody cool about an extension email with?
Yeah, over there, the table on the right-hand side.
Both of these don't appear to be working. Sorry? Both of these. Oh, this one doesn't work either. Only that one.
That's pretty much it. I don't have any, I mean, it's just a very snippet, and for you is a straightforward. When I showed this in conferences, I kill people, but for you is fine probably. So that's, I don't really have.
I'll do the microphone.
Oh, sorry, I forgot. Sorry, people at home, I forgot. I'm sorry. Any question on this?
So we actually have a working.
Microphone.
Sorry. We have a small demo of the HTTP server with Milo. Maybe I can show you like the proof of concept that we created. It's working. It can parse very simple requests and send a response. So maybe we can show you that.
No worries. Oh, I don't know. Okay. So yeah. Just want to check that it's working. It should be working now.
Oh, yeah.
You got the copy.
You can't type
Yeah, I don't know.
what you said. Type it.
They just.
I have an abundance.
Okay. This looks like. Yeah. Thank you so much for the help. Yeah. I'm pretty good now. I was gonna see how. We have a while longer, right? Our session.
I think half an hour more. Yeah, 24 minutes.
Is the session finished?
I can show us a small demo.
Wait, no. Are you sharing on Zoom?
One second. Yeah, one second. I guess which tests are not working. One. As usual.
Okay, I can share. I can share.
Actually, we will like to get. No, actually, that's yeah. Okay.
Where is the?
Very quickly. Actually, one thing we would like to get feedback on the UX that you see here. I mean, this is a POC, of course, but if you see anything clearly absolutely wrong, let us know right away.
Okay, share screen. Okay. So this is, let me hide the floating meetings. Okay. So this is an example on how this is a simple test, but like this works already, and it's HTTP server that parses with Milo a very simple HTTP request. And the way that we created it is like you create with the constructor, you like instantiate the HTTP server, then on listen, you start listening to it, and you receive a request object from the web spec, web API request object, and then you can send a response object, just like those are the request and response objects from Undici. Yeah.
Did you change it from what I have?
Yeah. The PR was not updated. So this is like a very small example, and the implementation, what it does is basically like it's a switch when you can choose the HTTP version, and the rest is implemented with Node.js API as a native add-on. The C++ implementation is not the best because I've written it and I'm not very good, but yeah, it can parse like very simple requests. So if you are interested in improving this, you can join the web server framework. Yeah, it can parse any request, of course. It's Milo. How it does it is whenever it receives a request from the socket, it creates the parser and do all the Milo stuff that Paolo talked about before.
So a few remarks here. In theory, Milo is capable of parsing the entire HTTP protocol. I followed the spec basically from very beginning to the end. One thing that you need to basically consider that in order to work now, if you look on line 40, the idea now that's for the Milo API is that you basically, when you attach callbacks to Milo, you bind to some context. The context should at least contain the input for your convenience, but it could be literally anything. It's up to you on how to implement them. Because basically when, for instance, in this case, Marco, where do you set the callbacks? Where do you set the callbacks?
Can you all hear me on here? Yeah. Okay. Yeah, we're working on the issues. We're not sure what happened. Something got turned off on our end.
Maybe, yeah.
Laptop.
So we're just going to use the laptop. So the folks who are going to talk will just unmute on their own for now.
Yeah.
If you can't hear somebody on there, please speak up and let us know that we're doing it poorly.
Sounds good.
Sorry, we are having some technical issues at the venue with the AV setup. So folks in the room are going to just use their microphone on their laptop. Okay, Wes, go ahead.
Yeah. So I do have a couple of questions. So do we need to have a high-level API design discussion soon? Or are you all planning on more working from the bottom up? Like, this is the first time I've seen this new code, which is awesome that we actually have like a functional HTTP thing, which is with the web.
Does not do everything, of course. It's like a very
Totally. Yeah, but even that is, I think, an exceptional start. We wanted that for a long time, and I think we just are now getting there. So I'm wondering what do you all think the next step is? Do we need to write an API doc or something that shows like what our intended API is? Should we start writing tests? Like, what do we think needs to be done?
Well, while Marco set it up, on my, can you hear me, folks, at home, right? Just in case.
Yeah, should be good.
Should be good. Okay. I think that we should. Let's put it at least this way. Sorry. Okay, I cannot look at people. I think that we should start designing the APIs. Maybe not in the very details, but at least we get an idea of where we are heading, at least on the high level. For instance, also defining how many layers we want to define. For instance, HTTP server, HTTP1 server, TLS, then so TCP, then eventually, I mean, just ruling out just for sake of an example, because also this way we can also split the work. That's also another good point, right? Because so far I was only focusing on the parser, for instance. Then, but on that one, we also need to sync on the parser with the other moving pieces of Node, for instance. Because if we use Milo for the new HTTP1 client, we might use it for Undici if my PR ships, and for Node. And in that case, I would avoid, like we did in the past, that context. At the moment, we are using two different versions of LLHTTP in the code base. One for Undici, one for Node. One is C++, and one is the...
Recording in progress.
Oh, yep. And then I mute.
We decided that, so but basically we needed to move to something else. We didn't want to have any native add-ons for distribution purpose. So we did some experimentation and we settled on using WebAssembly. It has the build for that WebAssembly is very likely scripted. It's one of the most complex things that I ever saw. And it's a nice, like the setup for that, if it was not fit into a Docker container, a Docker image, it will be almost impossible to replicate on a developer machine. Just like I did once, then a few weeks later, everything broke because of updates and stuff. It's a very, like building WebAssembly is actually very hard. From C, C++, and so on and so forth, because there are a lot of moving pieces, there's a lot of dependencies, okay? It's not, and each one little change can just basically break the full Jenga of the setup. So this is, so that's LLHTTP. And we don't update it very often, to be honest, on the Undici side. It's kept up to date, but not very often. Okay. There is now interesting part, and this is where part of the reason Milo is we're chatting about Milo in this using WebAssembly is Undici HTTP parser is, or when we had both implementation anyway, was slightly faster than the C binding that we're shipping in core. And essentially it was due to the additional transitions that we had for, so it was due for two things, some additional copying that the LLHTTP binding was doing, but more importantly was due to the async hooks integration for the HTTP parser in LLHTTP in core. Because LLHTTP in core is currently exposed as an asynchronous source, even though it's not asynchronous in any form or fashion. And it's just a synchronous API, okay? And therefore, this is lots of reasons for that. Like, this is a big topic, but this is because it was done that way to debug certain class of problems, and that was why it was done in that way. But the TLDR of this is by not having to do that step, we saved a lot of, we did quite a significant saving. On top, it seems to me that the boundary crossing between JavaScript and WASM for certain objects, like buffer, like uint arrays, those kind of stuff, is slightly faster, but this is my, it's a feeling not based on numbers, okay?
Even more.
Hmm?
Even more. So,
Okay, here you go.
very quickly, one thing that I might double check, but looking at the source of LLHTTP is also that the WebAssembly version for sure uses SIMD everywhere on each platform, which might not be the case on depending on how you compile LHTTP on on the C++. For people not familiar with SIMD, and I'm not familiar with SIMD, is basically a way to parallelize execution of operations on a single CPU instruction, which speeds up a lot. Moreover, the WebAssembly version is exchanging close to no data to basically the things that you were talking about. Sending buffer to C++ does not happen in WebAssembly. That's why it's also faster, because we only exchange numbers. Basically, you always just send numbers, because the WebAssembly interface only allows numbers to be swapped as a input and returns of the functions, at least with the current proposal. There are proposals, but we don't care about them. And that's why LHTTP WebAssembly is faster than C++ in those places. And then it's matter of the WebAssembly machine, but that's once again another topic. Back to you, Matteo.
Yeah, that was my main point on the thing. One comment on the API that Marco proposed, I would not have the handler as a parameter of listen. This comes from generic past experience and API design. So the reason for that is probably a little bit long, but you don't want, like, you want to set it and then you want to call listen at a later time. And because otherwise you are colliding two responsibilities onto listen, and you probably just want to say either to pass it to the constructor or set it with a setter and configure the API for listening and then do the listen stuff. Because the way listen is currently done on the fact that, listen accept a callback in Node right now, it's one of the most horribly designed thing that we have, because that is not actually, like, if you take an HTTP server now and you do .listen, you pass the callback, that callback is added as a listener to an event emitter, which it's it makes it's
Also the variable API.
exactly. So it's generically, I would recommend to stay clear of like if we need to have a very high level API, a very shortened helper to do a 3 lines example code, something like that. That's a totally different. It's a different thing. Okay, I'm saying if at some level I have a way to say this is the listener, okay, and then now listen, and because having those kind of split thing will allow for some other stuff. While you're doing this, one additional requirement that you need to keep in mind, okay, is if possible, is request injection. Okay, so one of the biggest, one of the probably best features that we add in API Fastify is the ability to inject a request from JavaScript into the server, and this is currently it's one of the most grievous thing against Express. But this is not possible with Express because of how Koa maybe, but Express definitely on how they're setting up the sockets, how they're monkey patching the prototypes. Okay, so providing a known way to do the injection, like this is how you do it. Okay, and there is a public API to do this, and this is it's a built-in feature set. Okay, mostly because the 9111 so 9110 standard does not say what the transport is, so you could technically have the same implementation in process. So just have the injection thing built in will, as a standard way for testing, will allow you to do testing without listening to sockets.
I'll address this one, and then I will.
I can just. In here.
Okay. Very quickly, actually, Matteo, that comes out for free because if you notice, the listener. No, I'm muted here.
No.
Okay. If you remember the API that Marco showed, it comes out for free because the listener accepts a request and a response, which basically does not imply the socket at any level. So we already have that for free. So in theory, in the future, you create a server and you just call the listener without even my bad, the handler without even calling listener. We already have that. I guess I mean, we should double check, but again, anything we can do that. It's doable.
Use my mic on here.
Oh.
Better not.
Yeah. So, I personally would go for like having a thing that is like a container for like you handed the like function or something to handle the requests, but then the listen have that separately because like there's also like cases where you might want to listen like multiple times on multiple different things, and like it makes sense to also attach like the behavior around that to the listen. So like you might want to listen to like I want to listen on port 80 as HTTP. I want to listen on like port what was it 443 or something HTTPS. And like have each of the listens take the configurations for the different type of thing it's trying to listen to, but delegate all of that to the same handler.
Why don't you create 3 servers then? Why don't you create 3 servers?
Like you could make a bunch of separate ones if you want, but like just having like a single listen on the same thing, like if you can do that simply, like.
Okay, I see your point. I totally see your point.
Yeah.
Make sure you pass the microphone.
Yeah.
I think we also have a problem here with the 3 different protocols. Do we have some example code showing how that would work? Because we would need to pass 3 different ports, one for each protocol, or do we have a?
No, not strictly. Technically, you need to pass 2 ports. I mean, technically, even the same port, because if you think about it, HTTP 1 and 2 can live on the same port. That's it. Because depending on how you start the handshake, you can switch to 1 or 2. That's it. There is also auto detection on the HTTP 2, starting with HTTP 1 headers and then eventually shift.
HTTP 1 can only if it's HTTPS.
Yes, of course. I'm assuming HTTPS. I'm assuming if you say plain HTTP, then it's a different port or entity. HTTP 1 and 2 can live on 443 eventually. And HTTP 3 goes on UDP, so it's a completely different beast anyway. But to address your question, Stephen, the thing is that we will look into how to enable that specific use case. So depending on which basically protocol you receive, you use a different handler. But the idea that I also mentioned earlier, that since we are focusing on the high-level semantics, if you are on the high level, so the 9110 implementation, which does not imply, like Matteo said, the transport protocol, you can assume there is even a transport yet. You could have received the request via file, for instance. In that case, you don't need a different listener because an handler, my bad, an handler, because you don't even know there is a transport layer. If you are in the lower server, you will probably make sure that you already know that you're inside a HTTP 1, 2, or 3. The things that's my personal belief here, the way I still have to coordinate with people, is that I don't think we should allow an API to do too many things. I mean, if I need to handle 3 different protocols, on the lower level, I can eventually sync on the same socket. On the high level, I just manage as a single protocol. If I need to behave completely different, I start 2 different servers. It's much easier. It's easier for the user to start 2 different servers and write branchless, basically handlers, than for us to support an API which can eventually go in branching and it become more complex, and more complex means less performance. So we keep it simple and we say, please create 3 different objects. Probably is easier. But that's just my vision here. We just have to double check here. Done? Amazing. I knew that.
Okay, we're taking a break for 15 minutes.
Done.
I can just for another 15 minutes.
Maybe just one point, maybe we'll do that in the next, I think we do have a meeting next week on
Yes.
Tuesday.
Yes.
So I guess we can
Yeah,
have
we
a
can
focus
discuss
on
about
that.
it, yeah.
If some people want to join, you are all.
Please join,
more than
folks.
welcome.
Absolutely.
Yeah.
We need money because we are just few people giving input nowadays, which is actually dangerous. Stop us, please. Join. Prohibit us to do very bad things now, which will pay in the future.
Myself.
I never trusted myself. So
We only handle XML.
oh no. Next after
April
an
Fools.
XML passer. Why not?
We missed our April Fool's opportunity.
Yeah, by 2 days.
Node.js is shipping new HTTP that only works with.
Give me chills with
XML.
Not very bad. That was horrible. Anyway.
So you're here.
Sound check again. Can people joining from remote hear me?
Oh, they're gonna control us.
Yes.
So Robert is not here yet. He probably has already landed, but probably on the road. So any concerns about starting the tooling session after the break? Have you prepared the session, the tooling session? Because Robert is not here yet. So,
Yeah,
Oh,
get a small
okay.
agenda, like I'm good to go.
Okay.
Oh, I mean.
Remote participants, I'm not sure if anyone is, trying to join after lunch from remote, but
Well, that's the thing. I did have a couple, well, mainly Yannis is on the East Coast. I was hoping you could participate because I want to discuss a Node run.
Yeah, he's
Subcommands.
for tooling.
all right,
Yeah. I was hoping to get him if it was in the afternoon, right?
right.
So if there's a nod.
Yeah,
I mean, I don't want to bring Corpac because that's gonna take.
Yeah, I don't know.
Maybe you could do Corpac because then we take a break. We breathe.
Is there a core pack, like what's the agenda?
It's like.
You mean Corpac after break? I think that's probably too early.
That's 2 sessions. Like Corpac is like 2 sessions.
Because there will be, I think that will be like where we have the most remote attendees. So probably
Yeah.
not a good idea to start now because a lot of people are in the US or
So,
North America.
So yes.
Yeah, because.
So no, this was chatting if we could just move the tooling room.
Yeah, yeah.
I can start with HTTP next client thing. It's not, I can wait for Robert, but I would prefer to wait for him.
Okay.
If possible. I thought he would be here, but
Did you do Corpac? Like it's.
he told me he was landing at in London.
But no news this morning?
No news this morning.
Right, so maybe there was.
So
This is, yeah, he said, this is April 3rd, 8:55. Okay, and he told me he was coming, so, right, but is still not here, so.
So I guess the conclusion is that we'll start the future of it HTTP client without Robert because he's not here yet.
What do you prefer?
Well, it depends, if we can do the tooling. It would be better. But we can start with future of HTTP and then we move to we start with do, and then we do the tooling.
One thing that is very productive if we have everyone on board is that we can fast forward a lot of the current ongoing discussions, right? It's blocking the speaker, right?
Oh, for the Node run.
For Node run, yeah.
So you, is confirmed to come.
I'm hoping, no, that's the thing, he didn't confirm.
Okay, so this is, okay, sorry, I am.
The basic point,
I
I prefer having Robert,
I-
yeah, it's not confirmed for me.
slightly prefer to split them if possible, if it's not too much of an income. If it's not confirmed. I really, like, one of the organizers, and I think of the facilitator of the session, it should be, it should be here, like, to be honest, so.
You wanna try calling, just like.
I have his phone number. Organization, yes, just.
I can just do that. Yeah, you don't need to show me. It's all right. I'll.
We have 1 minute left to decide whether we are going to flip the tooling session or start with it.
Folks, any people objecting in doing the tooling session now?
Just to.
I mean, remote participants cannot object if they are not here yet.
Well, for the agenda, I kind of like just have, I think the important discussion, like I want to bring on subcommands and Node run. For the tooling agenda, I have the discussion on subcommands and Node run that I want to kind of hopefully jump into and fast forward a little. Like I know there's a lot of ongoing discussions on the PR, so I was hoping to, yeah, kind of fast forward these discussions. So I'm aware though, yeah, one thing that I'm aware, like, and I'm afraid is that the East Coast cannot join, like the folks from the Americas, like it's pretty early for them. So I was hoping to have that in the afternoon, like hoping that more people can join. So yeah, trying to decide here.
Okay, let's go ahead with the agenda then. The problem is people are arriving and Robert, which is the other facilitator, is not here yet. Yes, but
He's supposed to.
he was supposed to already be here.
Do anybody
But-
has his phone number or something?
Nope, I don't. Maybe somebody when re-registered. I don't know if Bloomberg does have it.
Right. Who-
Oh, sorry.
Daniel, yeah.
Registry for that. Who's the person I'm supposed to look at?
Robert Nagy.
Oh, yeah.
Easy if there's a phone number. We can call.
If you can call him. I don't have his phone number, so.
Yeah, I could. Yeah.
Hopefully it's the real,
Oh, wait.
it's a real number.
Yeah, look, it's fine. I am fine doing the HTTP. I can start with future of HTTP if in case. I just need
We
to.
have 1.5 hour for
Yeah.
the HTTP
Yeah,
and
yeah.
Rishi, so maybe that's enough even though.
Yeah, probably. Just need to go to the toilet.
So we're planning to stick to the original plan, but and we're trying to call Robert. And hopefully show up soon, but probably will start a bit late as well.
It's on those order of magnitude.
Hello. Hello. So we'll probably start now without Robert. And Matteo is going to like chair the session.
A good way.
Okay, Matteo is grabbing something to drink.
So, yeah, okay.
Stand guard for Robert. Is the person who's supposed to be in this session, but
It's okay.
AGY.
Everyone, let me start on the future of HTTP client discussion, okay, which is a good segue after the server part, okay. As you are all aware, we shipped Fetch, in Node. Hooray! You know, this is I remember when I did the first presentation of shipping the thing, I think back in 2018, something like that, in 2017, 2018, there is a slide deck of me and a video recording given of me telling how impossible this was and how multi-year, and we made this table in 2022 or something, 2023. So it's probably like close to impossible on stuff. Anyway, the part of so the decision that we made at the for Fetch was to split it from the current HTTP request command. Part of the reason for that, it's the current client in its current state. And I'm speaking with Robert that was supposed to co-facilitate this, but he's not here, as we said. It's close to unmaintainable. Okay, let me be clear when I mention unmaintainable. Okay, every single time. So first problem with HTTP.request and HTTPS.request is it's tied to the socket implementation, and it uses the same base classes of the HTTP 1.1 server. Now, this means that any change that you do has a chance of breaking Express. Sorry, this is the point of the this is the LDR of half of my discussion of the problem. So it's because Express modifies the prototypes and so on and so forth. So it piggybacks on a lot of things from there. So that is this essentially the biggest problem of that specific thing. And on top of that, it has some very odd behaviors and implementations being inside it, that every single time we try to fix one of them, it's whack-a-mole. It's pure whack-a-mole play. Like it's basically, there's no, like we came to the conclusion of to a lot of bugs, to those is probably not worth fixing. Like again, it's because there's no way we can fix them without breaking everybody else. Even people rely on that specific problem. So pretty bad from all intent and purposes, okay? So, and because of all of this, when there was a time of starting working on Fetch, we started working on it inside Undici, because Undici is has this kind of layered setup that allows you to, we have code this completely, so the high level API is completely split from the low level API, 100%, like they've completely separated with an interface. So you can essentially have multiple high level APIs with the same low level API, and the same low level API can even be multi-protocol. So it's completely split, as I said, it's completely two things, completely different, no big deal. Well, a lot of big deal, a lot of work, but completely separated, okay? Which comes to the current question of what should we do with HTTP.request, and what should we do with the people reporting bugs, okay? You know, this is a big, go away. Like, again, I'm not, this is, I have, if you want to send a PR, even if I receive a PR, we don't know exactly what to do, because from time to time we break some people in some very obscure way that we never even realized that we could even break them, because the way that we're doing, like there was a long bug about we broke somebody, and it was literally just fixed very recently after a few years of people reporting the issue, but nobody could bias. You know, it's as I said, it's a nightmare situation. Okay, so because of the split in Undici, we can deal with those cases in a much more predictable way. Okay, so it's, and in fact, Undici has certain edge case. It, to some extent, has a more robust test suite than the HTTP client in Node Core. Or for good and bad, which means also that from time to time, we catch a lot of bugs from Node, some bugs from Node Core that are not emerging until we run Undici test suite at this point. It's very extensive. So the TLDR here is, though, like the first question is, what do we want to do? Okay, I am laying out the question, then we can go them step by step to them. So the second interesting question about fetch, okay? As said, Undici has this layer, we call them dispatchers because the agents were the one on HTTP. So we call them dispatchers. They call that dispatcher because they have a dispatch method. So that's the gist, because it's a dispatcher. It's a dispatcher because it has a dispatch method. We needed an object because we also needed a close button, a close function, okay? So fun. So anyway, the TLDR on that was, however, in order to configure Undici, to configure fetch in Node, you need to spin up, you need to install Undici separately. So in order to configure fetch in Node.js, so
Oh, yes.
so fetch in Node.js works on its in a bubble, okay? And there is a global dispatcher from Undici that underpins it, okay? All the connection fetch calls this dispatcher, okay? Which is totally fine. But if I want to change it, I have no way of changing it from the Node.js APIs. I need to import Undici and set it. Now, because this is set on a global object using a symbol to manage this in a fancy way and support both things at the same time. It does work. People have been playing with a symbol, doing some very hacky things. I've seen some reflect a thing that they get the object, they get the constructor from the object, and then they call the constructor. Look, as I said, it comes the question of do we want to expose any of that stuff in core to others? Okay, this is a question mark. I have no good answer for that. I am just floating the questions to the group. Okay. Last question. Last question is about request, and so that last question comes for proxy. Okay, which this is related, slightly related to the problem. How many of you are aware of the proxy problem? Okay.
Which one? Which one?
Nice, nice. Okay, so there is the proxy M variable. Is Robert downstairs?
Yeah, he's coming up now.
Amazing. Okay, awesome. So proxy. So proxy is so there is a huge demand for people to support from users to support the proxy environment variable. So if you set the proxy environment variable before starting Node, it will automatically route the users want to automatically route the request to people. Now, the former NPM team, I think you folks had implement the proxy inside NPM somehow with an agent. Yeah. Is this correct? Yeah. So you have a specific HTTP agent to do this proxy thing and it's an external module from NPM, which, hello, where you see? Sorry.
I came, they took me to Victoria Street instead of Queen Victoria Street.
City card. Amazing. Okay.
Can I grab a chair somewhere?
Yeah, it's fine. Here we go. We are talking about HTTP client.
Excellent.
So I just framed the problem. So I was just doing the intro. So so there is a demand for the user, okay, and the current demand is an open. So Undici is starting to add support for this, for the proxy environment variable, and there is a PR open. So finger crossed, this lands. So Undici can have that support as an optional dispatcher. Okay. The key part here is do we want to have this exposed to the end users, and should this be the default? Okay, this is a question for the group, and in which version of Node should that be exposed? Okay.
What be exposed?
The proxy and variable support. So basically you can set up now this is making more complex because the proxy and variable support has no standard and multiple libraries implemented in different ways. So picking a choice here means, some user will be slightly upset. There's a long thread about all of this. So it's, I don't know how in NPM you solve it, but this is a good thing where you might want to piggyback. So, so let me, before we go and try to answer those questions, let me show you the, what is it? HTTP. I have a few slides for Undici. Okay, I am going to, this is one of my latest presentation of it. Yeah. I just let me just show them here. Okay. Okay.
Giving each other work.
Here we go. Okay, so where is it? Sorry. Way too many windows. Just a second. And Zoom. Okay. Share screen. Sorry.
This is Windows. Windows. Yeah. So Windows.
Where is it?
That's for all I've seen. I don't trust my English ever.
Yeah. That's
Let's do this. Okay. So you should be able to see this. Okay. So the so we have here we go. Okay, so you should be able to see this. So this is the gist of when I said the undici. Okay, here you have the request object, but it can be fetched, and then we have the set global dispatcher, which is this thing that set the dispatcher into a global accessible property using a symbol .for, so a global symbol, so different version of Undici can share the same thing, but also the one in core can access the same thing, and there is an API contract underneath. Okay, and which has its own specific version number. So we have even a number to increment if we want to change that contract. So, but the gist here is you have the agent, and an agent is just an implementation. Okay, we can have multiple one. We have the proxy agent to do with proxying. Okay, and to do with proxying. So people might want to configure that. Currently, this is not possible. You have, in order to set an agent, you need to create it, set some properties, and then set global dispatcher. And then you can do all the other bits. The important part here is the agent these also support mocking. So built-in agent also have mocking built in. So we have a mock agent built in inside it. You need to do any monkey patching to do to do anything here. So the actual thing here is we have a dispatcher, okay, which is an abstract thing that with another dispatcher base, funny enough, okay, it's two abstract classes with different level of split implementation, okay, and we have the client, which is the wrapper on top of a single socket, essentially. We have a pool, which is essentially a bunch of clients. Okay. We have a very smart pool, which is the balance pool, which is the smart pool. It's because it uses a very fancy paper to select which socket to use based on a very funny or maybe not, mathematical function, so that you can have use the optimal socket every single time, or the one that gives you the better latency. Funny. And then there is an agent, which is essentially a pool for each origin. Now, client can also include the HTTP2 client. Did we split them, right? Yeah, so there is HTTP2 and so on and so forth. Okay. So if you want to mock a request, for example, you have this, you create your mock agent, you set the global dispatcher, and so on and so forth. Okay, again, this can be completely transparent because the two things are split. Now, a dispatcher, and this is the interesting part, those things are dispatchers. Dispatchers are there because they have this dispatch method. That's it. Take some options and an handler to handle them. That's what it is, okay? And there are a bunch of other methods that are helpers. So we have dispatcher.request that uses our request handler. We have the stream handler with fetch handler and pipeline handler. All of these are internals. but those are how it's implemented. So the API, the public API is completely split from an internal API. It's completely split implementation. Okay, how is this? Is the interface of the handlers. Now we're going to talk in the next session, probably to talk about how we want to change this, but this is a different, this is a good segue, as I said, on the current status. So we have on connect, okay, on error, on upgrade, on response started, on headers, on data, on complete, on body sent. Okay, these are essentially all callbacks for all the various life cycle of an HTTP request, which means that we can use those to implement all sort of APIs on top. So it's, as I said, it's completely split from the two bits. Okay, and note that on data returns a Boolean, so you can it can pose the source. Okay, so it's the back pressure compatible and so on and so forth without using streams and event emitters and a lot of the other stuff. Okay. For example, one agent can be the retry agent. As I said, I'm just making examples so that people can, so you know what is currently possible with Undici and why people are asking why they want to have this in exposed in core. Okay, so we have the retry agent, which is essentially it's a retry agent uses a retry handler. It does retry handler.dispatch. Okay, and there is a new thing, and we also offer a new ways to compose this that we just shipped. So which I did. Yeah, this is not the API. So this is all slides. Anyway, the gist here, I just wanted to give you an overview of why people want to do those kind of questions, which, you know, remember recalling the questions that we need to make some decisions of. Probably not coming to the decision today, but I am at some point this will happen. So first question is, do we want to expose like this set global dispatcher API from within Node and ship a version of, like expose the version of Undici that we are shipping, essentially. So yeah, allowing this somehow, okay, at the top. And then if we want to deprecate, okay, go ahead.
Are you thinking,
So wait a second, Mike.
are you thinking of making it like node : Undici that you would get the access from? Like how are you thinking?
I know.
Oh, okay.
Oh, West.
So I think the first thing that we need to ask is it all right that Undici is like absolutely leaking its API straight into Node's API, right? Like that's really the crux of the question. Is that all right? That right? Am I understanding that? Are people understanding that the same way? We're basically saying like, why at that point, why don't we just ship all of Undici?
You do.
I know we already do. I meant expose the API. Sorry, to be clear, I meant then at that point, why are we not just exposing the full Undici API if we're letting this so much of the API leak into the Node API? It feels pretty silly to not just go all in and do the whole thing. Next.
Actually, that was my exact question. We already have Undici in Node. We're already using Undici because people are using fetch. Actually, Matteo, why we didn't expose from day zero? There was a reason, or was just it just happened? Oh yeah.
So I've been a little bit against including Undici in core because that basically then we can't change stuff anymore. Like right now in Undici, it's already difficult to change things, even if we do Semver major releases of Undici. And once it's in Node, then it becomes even more difficult. I think some of the APIs are quite stable. There's nothing much more to do with them, like these high-level request stream pipeline, etc. I don't foresee anything happening there. But like with the dispatcher API, I'm currently working on things on changing those, and I think the current one has some certain issues, especially in terms of composability. There are some of the methods that Matteo showed there that I have proposed removing because they cause foot guns that are very difficult to understand why it happens. I have a little side project I call Next Undici, where I've been working, trying to build different composition of dispatchers, etc., and been experimenting with that. So as far as I see it, exposing the request or stream or pipeline, etc., I think that's fine. I don't see things changing there. I don't see the stream and pipeline high-level methods being used so much in the wild. So I think the less we expose in Node Core, the better. But we should still expose the useful parts.
To basically say what paraphrase what Robert is saying is the stuff that we want to expose is the stuff that it to some extent gives some access to the lower level bits to allow people to change those dispatchers. But this is also the area that's probably where more work is needed, essentially, at this point in time. So if to show up why it's not a clear-cut answer. Now, the part of the reason was this was not done in the first place was because it's there was the question of, we are doing this implementation of fetch. Fetch is a standard, so we could potentially decide to switch it anytime, and nobody wanted to make a decision, a fixed decision. But then there was a lot of issues popped up on how do I change this setting? How do I change this other setting? How do I do? So we came out with this fancy, undocumented way of changing the global dispatcher from Undici, also affecting fetch, global fetch. So, and the fact that we are exposing the dispatchers is the reason why we need those things. Now, the handlers, these are more internal level API, even though they have a public interface, essentially. So, but the dispatcher use the handlers internally. So there's this question of where the thing blurs. So I don't know. I hope we responded to your to the point to your point, Wes, and so on.
You did, but we didn't answer it really, right? Like we need to, somebody's got to make a decision, right? Like on, is there a bad outcome that we're trying to avoid by, like you said, it's hard to change. Is that the only barrier?
It might.
I'm not sure we need mic.
It's my we have my policy.
Okay, we have a mic policy. Yeah, it's basically there are still things that might change, at least on the low level dispatch API. And once that's in Node Core, it's all, then we kind of get back to the state of things we are at now with the old HTTP client, where we can change stuff because the whole ecosystem depends on how it worked historically. So that's why I'm still in the, we should expose something, but as little as possible.
I mean, we could mark it as experimental, but we know where it's gonna end. Sorry, I had to, folks. I'm sorry. Sorry about it. No, I was also thinking that one thing that we might also to consider, I mean, about exposing Undici is that, I mean, you were not here, but previously we talked about the web server framework, right? But we never say that at the end of that framework, we might even move on the client side with the same effort. Because if we see that our API is good, we might say, okay, let's also now switch to the client for the same. That's Undici, yes and no, because it's not completely based on the request and response object and so forth. So we might even have a third way later, which makes things even harder, to be honest. I was just saying that the general intention, I don't even know. But the thing is that now, jokes aside, we might mark as experimental, or eventually the only thing we need to do is to basically outline a part of Undici that is actually going to be stable and only, stable as whatever might be, and eventually we just expose that part. So we have a really public API, a semi-public API, and a private API, something like that eventually. That might just be a choice, wasn't it, Marco?
So I was wondering why like the idea of exposing Undici as a module behind the flag, like node dot Undici, for example, behind the flag, and start moving like the HTTP client part migrated to Undici, so expose like all the low-level stuff, and then at some point like archive the whole HTTP client and move it to Undici as the real HTTP client of Node.
Not possible. You cannot mount one on top of each other. If you change HTTP.request in any form or fashion, you break half of the NPM. That to be putting it very, half of our users are breaking, essentially. It's you cannot layer them up because our HTTP.agent implementation is tied to the TCP, having a TCP socket or a TLS socket underneath. You cannot. It's not built for this composability of HTTP behaviors that users expect them to be possible. And so it's not, you cannot, like the only way to do it is essentially long-term way, and this is probably what Robert and myself would recommend, is to tag in the future HTTP.request as legacy, and then it's slowly yeah, it's literally HTTP.request is really for a lot of cases a foot gun. Consider it with Undici. We have support. We have close to have support for HTTP2. So we have the same client API for both HTTP1 and HTTP2 at the same time. So which is not possible right now with no core. So because of all those things that we talked about before. So I don't know. I am. This is my. Oh. Sorry.
If you plan to deprecate Node HTTP client, it will be the same as adding Undici to Node because you won't be able to change. It will be much harder to introduce changes that cause break even with same verb major, like you said. So if we plan that, why not expose it in Node? You said that we plan to deprecate a Node HTTP client. And before that, we also said that Undici leaking the API is problematic because then you will have much harder time to change it, right? So if you plan to deprecate HTTP client and in favor of Undici, we have the same problem with Undici. That you can change it more easily. So why not exposing it, because you're already gonna have that problem?
So why not expose it already, since we're gonna have that problem anyway? But I guess the point is that we try to expose as little as possible so that the problem is as small as possible.
And probably also to give you time to minimize that sort of stuff. So like you sort out the things that you do want to expose, polish them-ish.
I mean, at the moment, there are parts of the API that at least I intend and hope that we can change. So that would be a little unfortunate to, make those public in the node. So that I think the parts that are stable already, we could consider exposing, but nothing more than that, at least not now. And just adding to what Matteo said, both me and Matteo have spent a lot of work and thought into trying to fix the old HTTP client, even things like, implementing the old API based on Undici, and it just doesn't work. It's not possible, at least not with my expertise. So.
Next one.
This may be a naive question, but is the API surface layer something that could be worked together with other runtimes, like to make it more, to ensure that essentially you're not going to introduce something that is going to get deprecated? Could we get some consensus across like Fun or Dino or like somebody else with the HTTP client, like the new kind of APIs that are coming out of NDG? Like if you're trying to bulletproof this for a long term, you know. Yeah. Well, that's fine.
Okay, funny bit. These I've recently discovered that NDG runs perfectly on Dino, and it's actually quite used because Dino by default does not speak, is not able to do HTTP call over a unique socket, while NDG supports it. So if you want to do a HTTP call over a Unix socket, you use Dino, you use NDG on Dino, and it works perfectly, which I've been absolutely impressed by both our engineering feat and their engineering feat. Okay, I am not, as I said, nobody has tested it. Okay, like it just worked out of the box. There's no test on us running on Dino and from Dino running NDG. So it's completely blind, and it works, which it's speaks on the impressive scale of this thing. Now the API is very low level, so I'm not 100% sure if it's worth standardizing with other runtimes. Mostly because why would they want to implement it? Okay, if it's to the point of it's an interface between lower level implementations and higher level things. I think standardizing is probably just at this point an absolute waste of time, but this is my personal 2 cents. It's oh, but I know you disagree, but I can mostly because this was born from the fire, I would say. Okay, this API was born from bringing it up from nothing and pulling things out, and I don't know, it works. It's just very low level and very much like, why would you want to standardize something that sits underneath fetch? And this is the question for the group. Okay. I don't know if anyone. Sorry. Like this API, this dispatcher system sits underneath fetch. Underpins the internal flow of HTTP requests, outgoing HTTP requests. I don't know who is the queue. But
Oh, sorry.
no, it's fine.
Sorry, and Dino implements this compatibly?
No.
How do you have it that it works properly across them?
They really import NDG. So users import NDG and they sit on top of Node Core API, and because they implement Node Core API, they lift it in all our source code. And they implement all our Node API, then it works.
Oh, sorry.
Makes no sense. I don't really have anything to say.
But for the point of like the standardizing and like if this would be useful in other places, like I can definitely see the like dispatcher system being useful in the browser or things like that to like be able to intercept and handle these things. Like there already is to some extent that with the like, I forget the name of it, like you can like inside a worker like do all the like service worker, the like extra routing stuff. Like I can see the dispatcher thing being useful for a similar sort of thing, but with a less convoluted way of doing it.
I think in theory that sounds cool. In practice, I think that's gonna be difficult, or at least it's gonna take a very long time to get to that point. I'm not sure if we wanna wait so long. And then regarding the other runtimes, I think they are quite focused on fetch and making fetch as quickly as possible. So I don't see that being a priority for them at the moment. The other thing, like this is how I have been thinking, but maybe I have been naive, is do we even need it in core? Why can't it live outside of core and we just deprecate the core HTTP client? Most people think that we must have an HTTP client in core. I can see pros and cons of that also. I'm just saying that there is an option to just leave it outside, and then you have its own, you know, Semver major cycle that is independent of Node.
I think that's actually a really good point. Like, if you're building something that doesn't require the network, let's say it's, you know, local only, file system access only. That's an interesting point to just say, like, do you need a HTTP client? But yeah, I would just want to basically plus one.
I raised my hand to do it. Are you not? No, I can have it. Let's quick, okay.
In terms of like deprecating the built-in HTTP client and agent, all that sort of stuff, that was one of Node's like original things. So like it may be really practical, but it's like, oh, what do we do now? I mean, I know we do a lot of stuff, but it's like one of our original things. So it's like, it feels like we should have something else.
Yeah, I think I agree with that. And I think we actually have some pretty clear precedent that having some APIs that are going to work in many environments is a user want, right? So like there are libraries that bridge the gap between HTTP requests in the browser and Node, and they're quite popular. So I think there's some, to Darcy's point about like, and Steven's point, I think also about using it in the browser, I think there would be a lot of user experience left on the table if we didn't seek some way to bridge these gaps for our, whatever our recommendation is going to be. And in the past, it was http.request and that. If we're moving towards something new, I think we should have answers. Whether if that is, it is in user land here, that could be fine, but I think you're right that it would be quite disruptive to fully deprecate the HTTP client as is without a core shipped alternative. I think that would look pretty weird to the user base. Or you're next.
That's more of a
Go first, that's fine.
Yeah, it's a little bit of both though. No.
Both are important.
It is, right, that's yeah.
I mean, in general, we have that problem not only with HTTP, it's a problem of that with all these modules put together, we have one Zember major cycle. We don't want to break users. So like we could have a different package or we could have something built in. That's always the struggle to decide upon. And as such, I do like the idea that Robert brought up earlier about just removing documentation, but I don't believe removing is actually possible. What we could do instead is to actually give a recommendation in our documentation that really strongly highlights, hey, if you consider using this, please consider using this first, to give a recommendation to a library outside of Node, because then we could have that faster release cycle with Semver major versions, but we still have a recommendation that this is what we believe is the right thing to use.
We're over time.
Yeah, okay.
I just let,
Okay.
also, the next one is when we reach the next major, so I guess it's kind of all intertwined. So but we have no break after this, so just be aware of the time.
Okay, I will be fast though. I like Ruben idea. I also would like to recall what we spoke about in, I guess it was Vancouver last year, when we mentioned in the next 10 initiative, if I'm not mistaken, about why we don't start publishing recommended libraries in the @Node.js namespace in organization in NPM, right? So we might do like Ruben says, hey, we keep it Undici outside of Node. We ship it as @Node.js Undici and say, if you want to use it, we suggest that you use this one instead. and we give the community the sense that when we publish something under the Node.js organization, it's something we specifically support, but it's outside of the release cycle of Node, so we can actually are free in evolving the single package as we see fit. So people can apply the same verb measured things in as they see fit just for Undici, and eventually, for instance, upgrade another package, and so you get the idea basically. But we need to be more active and say, this is our organization, that's what we directly support, and we directly develop every day. Unrelated to the Node core release cycle. That might be an idea.
I think we're going to get ourselves into the same problems no matter what. Right? I mean, we're one way or the other, we're going to end in the same spot. So, and I think that users are going to say, this is confusing. They're just going to be confused, right? I think, and that's, I think maybe we just have to bite the bullet and say, I know it slows things down, but it's the right user experience to just have the HTTP client shipped with, and maybe it is major revved, slower or whatever, but like in the end of the day, that's kind of what the users probably want.
Sorry, could a compromise be that similar to fetch, we expose the new API, the request API as it is with those, it's quite simple. It's not very complicated. And then that's implemented with Undici. It could be implemented with something else, but basically we introduced this alternative API to fetch and just that part. And then we ship that, and then we ship our Undici implementation of that API. And then we have, a simple works for 90% of use cases, alternative to the HTTP client. If you need something more advanced with proxy agent and etc., then, we can refer to Undici or something like that.
Sorry, folks, one very bold sentence here. One thing is that we can't always make our users happy. For the greater good, we have to make them unhappy somehow, and where they have to, write 2 more lines of code in order to maintain compatibility, please. Otherwise, we lose our mental health, as we see in some places. You know what I'm talking about.
2 lines, too much.
We're actually coming back to how things are documented as well. Like one thing I'm often missing is how we give users recommendations how to really use something. We have just a plain API, hey, that is used like this and this way, but there's never actually, why is this used? How do you use it properly in application? And maybe we should consider this for our future documentation to have a stronger outlook on, hey, what is your use case? And that is how you would solve it. And then we can actually also recommend things like at Undici or whatever. So many hands that I'm up, I'm not sure.
Russ,
Raise for him. That was me. So we have the new and improved Learn section on Node.js org. And that's what we're starting to do with it. So like I started an article on how to use the test runner and like the good things to do with it in various use cases. So I think this would probably be an excellent article or post or series of things that we could put on there of like, okay, we have the main documentation that says like, this is what the things are. And then we have the Learn article of like, do this. That's it.
So to make things nicer, of course, ironically, we have absolutely no documentation for fetch in Node Core. 0.
Oh yeah, we wanted to do.
Yep. We don't. No. Well, we need something because in order to customize some of the behaviors, we need this. They need to know about Undici.
Could have that today.
So right now we are essentially whipping people into problems because of that. Okay. Now I'm flagging it. Okay. It's this is a demand. Okay. There's probably a lot of people. I'm not the best person to write docs, so I'm not trying to. Okay. But there is when I do, people complain. So don't. My brain is what it is. So I'm probably not the best person to write docs. But if somebody can, this is a task. I'm chatting with Claudio and so on for the Google Summer of Code. This is a big thing that needs to be essentially, is completely missing right now in our bits. Yeah, this is completely. Well, yeah, it's, I don't know, one line. One line and.
Why do we need to, why do we want to diverge from the MDN model?
Because it has some differences.
Oh, I see. I see. Okay.
Just a thing that you showed up.
Sorry.
Go ahead. No, go ahead.
So there's actually a strong reason for me to also include documentation that is not directly related to Node or to document things, how to use them, because at the moment, when new people are coming to use any Node.js feature, they're going to end up in Stack Overflow and get a documentation of 10 years ago. When they are, or I mean, that's like one case, and another would be some random blog somewhere talking about things and to use Express, and Express gets new users day and day and day. And that is crazy. I mean, come on, like that is really not the ideal implementation for web server. But it is the default. And everyone knows it. Everyone will use it by default. Why? Because our documentation doesn't tell otherwise. Why? Because our documentation is not found on Google as the first hit, which is a very, very big problem. So we have to figure out how to make things public, how that people understand things by going to the Node.js website. This is really essential.
Yeah, I'm not sure about the UX point of view from that, because a lot of this, like Google rankings, a lot of it is organically, and a lot of people like don't. A lot of please. Trying to have a chain of thought here. So the thing is, a lot of, especially, well, let's say the long tail of developers, right? Like they are like, well, I've been in that place myself, right? Like a lot of times it is way more, how to put it, like docs can be kind of intimidating for beginners. And a lot of times what they seek, what they're looking for is actually the Stack Overflow who will take their hand and like guide them through, like, like getting their thing running, like they're just, yeah. So they kind of want that copy and paste experience, and they trust like these places, Stack Overflow and everything. But to one point that I before that, I wanted to just kind of piggyback on the documentation story for right now. If the code that Matteo showed us like is actually the way to customize the Undici today, that should be in the docs today. Like that should be there. Yeah. Like that's already. Do you want the mic? Yeah. Okay. Yeah.
Yeah, I just wanted to add on the topic of documentation about Undici that we had many issues about the garbage collection, like people opening an issue, hey, you have a memory leak in Undici, and we like it happens a lot that we link to an article saying, hey, because this is how like the garbage collection in Node.js is different from the browser, so it works in a different way. And I think this is something that is really important to have right now in the documentation of Undici and Fetch to start documenting all this kind of implementation differences from the standard. So like if someone opens an issue on memory leak on Undici, then we need to document it.
On that side, yes, there are a few differences. This is one of them. Okay. There is also one thing that we need to change in Undici Fetch. Okay. Now that we finally have fixed the finalization register implementation in Node, this is a major pain for me. So I've been eating this for a year or so, and now it's fixed. Okay. We could implement it inside Undici. So that whenever the request or response are both collected, so the problem is, okay, let me rephrase this. Half of those issues that Marco is flagging it's because on the browser, if you have a fetch, you can do a fire and forget fetch. Now, this is nuts. Okay, I don't understand why this is even a good thing to do. Why in your right mind you would do that? But basically they do an HTTP request and they don't read the response. So they don't consume the response. And therefore they do not clean up the underlying resources. Okay. And therefore somebody needs to go and clean this for them because they haven't done it. So it needs to pass down clean it up and throw it in the bin, okay? And the point is, underneath there is a file descriptor, kernel resources. This is a full wall thing. So the best way is to actually clean it up. Now, there is some lower level mechanism in Undici that eventually it's not a complete leak in the sense that it eventually those things will time out and will back. Because of the timeout, the underlying resource will get cleaned up, okay? But it's like in the order of minutes probably right now, if not even more. Okay, so it's probably not even, yeah.
That is one reason to have Undici in core, because we could maybe solve it if we did something in core that provided some kind of guarantees in terms of garbage collection.
Yes and no, we could do it outside right now. So it's possible right now. It's just a lot of work, but it's somebody with a lot of will can take it and make it happen. Okay, especially for fetch. This is a fetch specific problem. Okay, and they are used to, oh, I'm calling fetch and I'm not reading the response. Yeah, sorry. This is my lack of basic understanding of the network stack. Okay, so anyway. There's a question, Jay, or you're?
No, I just going because I'm in there's no one else in the queue. But about the garbage collection problem, I have a session tomorrow about native memory management. I'm not sure if we can expose like something to user land without an add-on. But one thing that we've been looking into is migrating the native objects to OilPan, which allows you to like do something when something goes away. When a socket goes away, for example, but we will need to migrate the socket or like something, anything that's in the native layer that Undici is building on top of, we'll need to make that thing managed by OilPan so that when the JavaScript wrapper goes away, we can invoke something. That would be a lot more reliable than using finalization registry, because finalization registry uses a different mechanism that's like less reliable. Or like the spec tells you that, be aware that it may not be called at all.
True about OilPan as well. You cannot count on GC ever calling any finalization.
But like during shutdown, it's like, I guess it's more reliable than finalization registry.
I mean, in the browser. In the browser, I would expect the browsers to implement some kind of guarantee on when the fetch stuff gets garbage collected. So it's not just, never.
In the browser, you have a different problem because the browser, I'm pretty sure that the browser, once you change the page, will destroy without even cleaning up in the proper way. That's my assumption there. It will just kill the JavaScript runtime and that's it, and we'll start a new one for the new origin. And that's, which is a problem that which is call it a feature that they have, because they can say, the user has switched page, I don't care anymore, I can throw everything away. We can't, because we are a long-running process. That's why. On the browser, I think to address your question, why you issue a fetch without probably asking for a response, I would say, for instance, where you unload the page, so you let the request start and then you don't care if it ever finishes because you're closing the page. So you let the socket start, you send the request, done. Might be the only good usage for that. Yes.
So this is, okay, so just want to bring back a little bit the discussion, okay? So the first point, it's should we, if I'm reading the room correctly, there is a good sentiment in first documenting Undici, and the second one is slowly moving to expose part of it inside core. is this seems the good outcomes of the discussion. Okay. I have one more question. Is do we want to expose the proxy environment variable parsing in 22? This is a very immediate question.
Say yes.
For fetch, at least, or for everything, but I don't know. This is a good question. Is like technically we could, okay? I will need to shape a very quick new major of Undici, but this is easy to do to some extent. And or even not, like you could even consider that. Just here we go.
Actually, I believe, and like especially you and Ronald here, both most experienced in how stable things are in Undici. So who's better to judge upon, okay, we want to chip this besides you?
Well, this is a question of features, not about the stability. Like stability will come. The parsing it's a new PR submitted recently. So it's not going to be stable. It's just, is this a feature that we want in 22?
Well, stable is always relative, but at least from a Zember major release cycle in Node.js, and at least from the interface, pretty much how things are. So I guess, again, like you're probably the best to judge upon. And when you give a recommendation, I believe that's fine.
Yeah, you started.
I'm sorry. Yeah, Matteo, I know you mentioned, okay, maybe moving on to exposing some, like maybe a smaller surface of Undici in core. And more of a DX point of view here, right? Like, but do we want to maybe have a rebranding, kind of renaming of right Undici, like, because it doesn't really mean much for, you know, in this, think 10 years from now, right? People jumping into
Okay. Here you go.
Your turn. My turn. Yeah. So the that was sudden. Moving on to the how the next version of Undici, and it goes back a little bit to the interface and how it should work, and this dispatcher API, etc. I'd love to have some help or thoughts or comments or how that should look. I have some ideas if I could share my screen, and would love to get some feedback on that, because it's, yeah, I need basically help. So how that should look and how we do composability and the UX versus the options, etc. Am I a panelist? Yeah, so I need to be promoted first. Who promotes? Thank you. And then I can share my screen. Does that work? Sure. Oh, excellent. Can I put this down while I'm talking? All right. So cool. Yeah, here. Paolo, can you help me?
Absolutely.
How do I make this? I have to make it.
Control your plus. And plus.
Command plus. Where is my plus? Sorry, I'm. This is. Stress. Yeah. Let's zoom in. Here we go.
A few times.
I'm not so good with Mac keyboard shortcuts. That's good. Is that readable? Yeah. So okay, cool. So we have this basic API that Matteo showed you earlier. Like this code and headers, right? Now we would like to be able to change the behavior of this request. Add retry, caching, automatic redirects, following redirects, etc. And we recently landed a new way of doing this, where today in request, this is already sent earlier, you can send in your dispatcher. So then it doesn't use the global dispatcher. So then it would look like this. And what we just added is we added a compose API. And compose basically does that. It takes a dispatch. You can think of dispatch as basically the dispatcher.dispatch binded to itself. So we could have sent a dispatcher here also, but to make it simpler, we just send dispatch and then the options. And then from here, you can, dispatch a new, change the settings and change the path. And then forward, actually, it goes like here. How is it now? I have a brain. How is it, Matteo? Brain fog.
Just slightly different. It's a function that returns a function.
Yeah, like this.
So it's a function that returns, that needs to return a function.
Yeah, like that.
Because it can be called multiple times.
Yes. Right. So, and now, I can change what goes in here. I can add, a retry on the body. So if I send in this can be async. Yeah. So, you can retry the body, and you can, follow redirects, etc. And you can just build up this chain of dispatch functions. And then, this will be used by the dispatcher and the request. And we already implement some, in the library. I think it's under interceptor. So you can have like interceptor.retry 3 and interceptor just redirect, max redirects 3, redirects 3, etc. We could also implement, right now request implements like signal handling, but you could remove that and then create an interceptor.
Mike, speak closer to the mic.
Yeah, you could create an interceptor that, abort on signal and then send in the signal here. And, interceptor throw on bad request. And you want to throw on 400 and 404 or whatever. So you can basically compose up your agent here with all the different behaviors that you want.
Can you
Okay, I'll just hold it and write with one hand. So this is very nice, but the problem is that, if you want to have different settings for each request, then this becomes kind of slow, and it's not a good UX per se. You would usually, set this globally, and then you always use this agent, set global dispatch. Sure.
One thing that you consider this, for example, I have written one of those interceptor for adding automatic OIDC integration, so that if you want to talk to another service and you set it, you configure the client with your, for example, client ID and client secret, it does automatically do the OIDC dance to get you a fresh token every now and then, and it's completely transparent for you. Just to make an example of what is possible with these kind of APIs. Other things that other people have been doing are, for example, a digest authenticator with APIs. So I don't know if you know about HTTP digest authentication. You call an endpoint, it returns a bad response, a challenge, and you need to call it back. And it does all of this dance automatically internally with this kind of interceptor patterns. And you can essentially, the sky's the limit to some extent. I even did a full agent that allows you to route HTTP requests completely in memory. Because it's completely, it's just APIs now. So there was a question from Paolo, right?
Yeah, I was just thinking this, looks fine, but have you ever talked about a class-oriented approach for this? Since you're already using classes for dispatchers and so forth.
Yes, and we moved away from it. Because a class, so the point, if you use a class, so the problem with the class is that underneath you have these interceptors and you have full agents. Full agents needs to know about the pools and the clients and the socket, and these do not. So if you know if agents have a close and destroy method, okay, you can close an agent, you can destroy an agent, but these do not because they're just passing through data. Okay, if you need, otherwise, the what we were using before actually required you to actually manage this state yourself, and this was pretty bad. I don't know. It's was pretty ugly to see in all intent and purposes.
Then my suggestion here for this API, over document it. Because as you know, I'm familiar with the Undici code base and I initially struggled to understand the API. So over document it.
Oh, we just shipped it a few weeks ago. So
Yeah, that's why I see.
so this is new stuff. Okay. That's an intercept.
This is how it would have looked if it was a class. And it would always just be boilerplate of forwarding the close and destroys to the underlying dispatcher. So it becomes a lot of boilerplate and a really bad DX.
I would say just over document. The thing is that over document the terminology, also dispatcher, the handlers, the meaning of those. If you over document it, I guess it's fine. I like it.
It's the Undici docs is horrible.
Yes, I do.
It's
So I'm just wondering, so you're trying to get feedback on like the API right now, right?
Yeah, I'm gonna get to my actual question.
Oh, okay, because I thought that's what you were gonna ask, but I was just gonna say in terms of composability, like my expectation would be that what Matteo said in terms of being able to create these kind of flows and be able to pass that into maybe compose would be nice if that's not just a set of arrays of steps for the interceptors, but yeah, if there's already an easy way to do that, that's awesome. It's like basically, like I said, it's middleware, right? So like if there's an easy way to pass the middleware into that, that's great.
So my question is, when you talk about exposing all those API, you mean adding them into the global dis or create, like, how do you plan to expose set global dispatcher into Node?
It's already exposed over a global symbol.
But
that's how you configure fetch today.
okay.
So
So that's
The secret way.
yeah, it's not documented very well.
So the answer is yes as a global.
Yeah, so we already have set global dispatcher. So what I'm proposing here already works to a certain degree. But there is a problem with this is, you know, if I want to have different settings per request, you know, I have no way of overriding these settings right now on a request basis. And that's a little bit where I would like to have some ideas or feedback on how to achieve that. I mean, I could make a here max redirects option that I send in, and all of the interceptors would get this option, and that would work. The problem becomes when you start building a lot of interceptors and you start having, you know, name collisions of settings. And I could have two retry handlers here that depending on, you know, if it's before the redirect, I want to retry in a certain way. And if it's a failure after redirect, I want to retry in a different way. And how do I pass down those options?
I mean, for namespacing the option, you might have each interceptor you set up there to return a unique symbol you use for scoping the options, for instance. But my question is, which is also why I raised my hand earlier, can those options be, I mean, can be grouped? For instance, if you declare those four interceptors in a variable, and you pass it in an agent, and then you pass in another agent, do they act as an independent one, right? So you can eventually include portion of those handlers in, interceptors in different agents or not? You can, because at the end of the day, are just a stateless function, right? Okay, so you should.
I mean, you can give it up. Sorry.
Yeah, go for it.
You can let when the user creates his global dispatcher, you know, so have these kind of symbols for their options on a per request basis, but it's also a little clunky.
user to provide a SIM.
And I'm also fine with, shipping this without having this possibility of overriding on a per request basis to begin with. I'm just a little unsure how useful that would be in practice. You could also, create a new agent every time. Yeah. Well, you're not creating a new agent per se, but you're creating the whole middleware sequence again.
Yeah.
So here's my get global dispatcher.
I mean, my suggestion here is that if you think that user might want to, for instance, customize a retry handler, for instance, the user should provide a function which encapsulates the default one. I wouldn't say don't make it the default one too much complicated, and you aim for encapsulation probably. That's my suggestion here.
As much as I understand that we're trying to make this a well thought out composable API, is there any situation where people don't want these features? And could we just avoid this composition problem that we're trying to solve by just like baking these into the agent by default? Like, I'm asking, why don't we just make them not? I mean, people need these, and I would guess nearly 100% of the requests that they're going to make, they want this. Whether they actually do it, maybe they don't because it's hard and they're not really sure what the settings are. But I think they actually want this to be handled for them, and like usually would expect it to have a nice little option of just follow redirects true, right? And so like, why are we making them do this more complicated composition API, which introduces other problems around, naming conflicts and setting things across this, like when we could just make the default agent have this stuff all hard baked in?
First of all, some of those are actually applied automatically if you are in certain cases, or could be applied automatically in certain cases, okay? Depending on some of the flags, okay? So it's not necessarily true that, so in fact, HTTP.request has a max redirects flag, for example. Yeah. 11.request. Fetch has a few of those behaviors built in because of that, the spec and so on. So some of those are built in. However, for the generic group, it's very much a big unknown if you want to have, like, some of those came out of, oh, we want this feature, we want this feature, we want this feature. Other people said, no, we don't want this feature. Okay, so it's a little bit of yes and no. So it's, I can say, for example, one of those is actually pretty bad, which is throw on bad requests. I would say 50% of the population want it, and the other 50% do not want it. So it's really like 50% at this point. I'm not even trying to put it that way. So yeah, that's the gist. So it's
just on a side question, we discussed about the set global. Do we have a get global?
Yeah.
Okay.
So it has, yeah.
Well, it sounds like if 50% of people want one thing and 50% of people want the other thing, that means we get to choose what we want, because
Yes.
Yeah, but
or very quickly, just a very quick question. Is the once you create the dispatcher, is not you cannot modify it anymore, right? Is fixed. Let's say, for instance, let's say I was thinking, I get the, oh, actually you just wrote that you get the global dispatcher and you add additional behavior on top of that. We can do that, right? Okay, then it's different. And can you remove? You can't remove it. That might. I mean, at the end of the day, you have a list of middleware, so you can just drop from the list if you have the index. I mean, it's an array at the end of the day. Yeah, rotten, yes. Oh, I mean, because I was thinking that, because either the reason why I'm thinking this is that either you document what the global dispatcher does, so user can basically copy the code and paste, recreate another one, removing the interception they don't want, or you provide a way to decompose. I mean, it sounds very bad, but yes, let's go with that. That's my suggestion.
I mean, decomposing is just setting another option. And actually, and the other part is also, and that we have defaults. Obviously, every API has some kind of default. We just want to have same defaults. And that is very important. Yes, we want to probably have the use case that will fit for at least 95% of all users. Why? Because most users never read the documentation and just use whatever they read on Stack Overflow. It's very first thing is, and that's the API in general. Options, I don't know about. Like configuration, I have no idea. That's why they often actually instead look for a library outside of Node for doing something that is built in much better, because they don't check the documentation there. So it's, yes, we want to have good defaults, and it's just how can we change the options? That's what I understood.
So to connect it with the discussion we had just a moment before, you see those set global dispatcher and get global dispatcher. And that's kind of the API style that we are talking about that you need to use to configure Undici, even for fetch. So these apply also to global fetch, okay? And this is where we are saying you might, why people would want to configure this. Like what's one thing you're not configuring, Robert, here is the proxy agent, which seems the biggest demand for people, how to have the proxy agent work out of the box in Node. And that's where the question lies on, that you see, this can get pretty complex pretty quickly if you get what I mean. Okay, so I just, do you want to talk a little bit about the change on the handler, or?
Yes.
One final remark. In Compose, if you accept an object instead of a list of interceptors, so each interceptor is bound to a key, you can use the key to both add and remove and eventually scope the options very quickly. That might be...
That's an interesting idea. Yeah, I can try that. So, but yeah, I think basically so far what I wanted to achieve a little bit is to explain to everybody. I'd love to have discussions over lunch and Slack later, etc. So that's wanted to bring some interest to the issue. Now the next thing that we are looking at, December major, is when you do this dispatch, you send a handler, and the handler is basically when something happens on your request, you have to handle it. So we use this handler instead of an event emitter or something like that. And just quickly going through what Matteo showed, today the handler has an onConnect method that takes an abort. So onConnect basically happens when this request has been dispatched on the client and is starting executing. And then you get a function so you can abort it at whatever point you want, if you haven't already aborted it. Then you get an onResponse started method when the message from the server has arrived. You get an onHeader server call when you have the status code, all the headers. And then you also get a function here called resume that you have to call if you return false here or on data. Sorry, my one-hand typing is a little flashy. Yeah. And then if an error occurs, you get the error call in, and when it's done, you get a complete call with the trailers. There are some extra hooks here that I'm going to talk about a bit more. So when you're sending the body, you can have an on-body sent, and when the entire request has been sent to the server, you get an on-request sent. So, yeah.
Return false.
Yeah, so back pressure. Back pressure.
And
So,
this is why we don't use event emitter?
Where we don't need, we don't use node streams or event emitter here. So it's an API without those things. So if you return false here, then at some point, so what you need to do is you need to save this .resume. And if you have returned false, you have to at some point call the resume function. Usually, yeah. So first of all, these on body sent and on request sent are huge foot guns. I'm not quite sure why they were added, but I guess you want to have observability on, when you have sent your request and how much data you have sent on your request. The problem becomes when you compose this with a retry handler, for example, then your top level handler will get on body sent maybe 1.5 times too many, because you don't know which instance of this request retry this on body sent refers to. Or when you have sent the whole request, but then you're retrying because the response failed, and then this gets called twice. So I have suggested removing these, and if you need this information when you do your dispatch, then you can just wrap the body, the request of the body in some way. This is what I do in my custom interceptors to keep track of, when the body has been sent and how much of the body has been sent. So these are going to go away. I'm going to get to my questions. I'm just providing you with information now. On response starter, we're going to change to just start. And resume goes here. So you can start applying back pressure even before you're starting get the headers. And then for composability sake, because when you make these interceptors, you call on headers, and then you want to call on headers on the sub handler, etc., down the chain. But it's a little difficult to add additional information on headers. So it would be, in my opinion, better to change this to an object. Because, for example, the headers you get here is actually an array of buffers. So you could rename this to, then to your sub dispatcher, you could add something to that object that says headers object. And then you don't have to reparse the buffers to an object on every step on the chain. That does add the problem that you need to have some kind of convention on when you're building your interceptors. Otherwise, there's nothing to do there. Now, that basically comes to the difficult parts. My question is, for example, on headers, waits for all the headers to arrive and everything. You can't apply. You either apply back pressure before headers start to arrive, or when all the headers have arrived. Do you want to be able to apply back pressure on a more fine-grained level?
You're doing like request prioritization or something?
Because you could have on header field eval, then you can return false there.
Well, first of all, you're duplicating all the events of the parser, basically, whether it's HTTP or Milo. Basically, you're exposing all of those. You might want that, but all these callbacks will affect the performance probably, unless you can detect and eventually skip them and not call them.
Yeah.
Yeah.
But what you could do is, if the handler doesn't have this, then you don't call it. And then you always call this one. But then you have, in the cases where you're actually using this, then you still need to have the back logic for on headers, which cause you overhead for that reason. So I don't know if there's an actual problem here. I'm just curious if, yes, I have to work on my microphone skills. This is why I'm not a superstar. Do we need this fine grain, or is it just, over-engineering it? Does anyone have any?
I think we can edit later.
What?
I think we can edit later.
Yeah, sure.
Rather than
Yeah.
removing it.
Yeah.
I have a few suggestions on what you just showed there. First of all, don't rename on response start to on start, because it's going to be confusing. Because people might say, oh, but I started the request. The things that they might think that when the request started, and then there is the full cycle. So I would say you might add a new one, say on request start if you want, but keeping them separate. Otherwise, it's a mess. About your do you agree on that? Yeah. About the on body sent and on request sent that were also those one. I agree that they were confusing, but for observability purpose, track the first time you sent a request, considering the retry ender, and the last time you send the last retry, basically. So the people can say, oh, in order to get a response, it took me this amount of time. Because for observability, they just care about the timing, basically. So if you track when the very first attempt was sent, and when the current one, the last one, was currently sent, you should be fine, probably. And one last remark, which because I think you inherited this from LLHTTP, I would say separate on complete from on trailers. You might also want to pause at the trailers in theory, for any reason, before signaling that the message is totally complete. Eventually, just saying.
We're running out of time.
And just one more thing, like return false is something that most people don't understand when they will read this code. So I would strongly recommend to change that to something with a name. Just a method call. Or, okay, we can give specific symbols or whatever. But instead, let's use a method normally. That is always best. Like people don't understand false.
Yeah.
So if you look at this this API for the handler, okay, this goes into the dispatch method, which is underpins all of it, which is essentially what is like this. The old API structure for this was currently being used, magically used inside Node.js for fetch. So it matters for Node because this is essentially this is the interface between Node.js and Undici at the lowest level. It's currently, as I said, it's currently versioned. So we have, like the symbol is versioned, so we could technically have multiple agents with different versions of it. Question mark if and how we should be doing that and bump that major and so on and so forth. So.
Are we gonna run into people then expecting browsers to have these features because Node Fetch has them or something? Or are we concerned about any of that, like aspects of how people are gonna be configuring this?
It's already happening. Like it's, we shipped an addition into the response object, and which for compatibility with Node Fetch, Node-Fetch. Okay, so we shipped it because basically they supported it, and we wanted to support the same test. We wanted it to be as one-on-one replacement as much as possible. So we lifted their test and we ran their tests as part of Undici. And however, basically we make the Dino people very frustrated because everybody thought that thing was, and also the Cloudflare team frustrated because everybody thought that thing was part of the spec, and it's not. So I currently have thing open and trying to put it in the spec because even the people in Watuji think it's actually a good addition to the spec. So probably this is going to happen. So I don't know. It's Robert. Do you have some specific question about this API? You want to answer?
No, I'm just grateful for interest, and I'm happy to further discuss it with you guys.
Lunch.
Lunch.
Can't imagine this not having 10 feet.
Okay, so we're going to have a lunch break until 1:45. 1.5 hour or like
It's in this room.
in the area next, like across that door, like go through that door.
Okay.
Oh, it's okay, it's okay.
Okay, see you in 1 hour and a bit more. I think we can, oh, yeah. Probably we'll start record and start a different one.